Welcome to Talking Supply Chain. In each episode, top supply chain industry professionals and the nation's top thought leaders join host Brian Strait and share their unique insights to help supply chain managers stay one step ahead of their competition. This is Talking Supply Chain. Hello, and welcome to Talking Supply Chain. My name is Brian Strait, and I'm excited to have Dr. Eric Garcelle join me today. Eric is head of technical marketing for Classic. Welcome, Eric.
Thanks for having me.
Thanks. Glad you're with me. Since I started hosting Talking Supply Chain, I've tried to find topics that are both interesting and informative for our listeners. Today's topic is both, I hope. I know I'm excited about it and learning more about this topic. We're discussing quantum computing. Now, before everybody goes and says quantum computing, I don't want to talk about that. Not everybody's excited about quantum computing. I think in many cases because it just sounds some grand technology, right? But Eric is joining us today. I think he's going to help us break this down a little bit, get us all excited about it, and hopefully understand why supply chain professionals need to know about quantum computing, and then how you might be able to take advantage of some of its capabilities going forward. So, great. Eric, I'm glad that you're with us and joining us for this discussion. I can't wait to learn more. Can we get started though? Can you tell us a little bit about yourself and Classic?
Absolutely, yeah. My job is precisely to do what you talked about, to try and explain the value of quantum, what it is, and why people should be looking into it. Right. I'm the head of technical marketing for Classic. My background is I have a PhD in physics and a master's in business, and figuring out how to articulate kind of high scientific concepts and make sure people can really understand the practical applications of some of this technology, because it does sound kind of Star Trek futuristic.
Yeah,
And not everybody knows that these machines actually exist, right? You can go on the cloud and use them. They're here, you know?
yeah. I think some people probably may have read about companies that are doing quantum computing. Can you kind of break down for us a little bit for our audience what exactly quantum computing is? And I think importantly, there's probably some key terms that you hear when talking about quantum computing. Can you kind of talk about a few of those as well?
Absolutely, yeah. I just want to say real quick, the company I'm representing here is a Classic, right? We're a software development platform for quantum computers, trying to make it easier to use all these systems.
Yeah.
But when we talk about quantum computing, certainly there's a lot of jargon and terms, and I'd love to go over them, right? Since we're in quantum computing, when we talk about classical computers, we're talking about everyday computers, using silicon-based processors and bits for their operation. When people talk about quantum computing, those are systems that use qubits instead of kind of binary bits. Sometimes people call quantum computers QPUs as opposed to CPUs or GPUs. Um, and actually, talking about that, right? A qubit is a quantum bit, right? It can be either a zero or one, or in a kind of probabilistic state of being, in a certain probability of being zero or one. And there's also something called hybrid computing when we're in the quantum space, and we mean kind of using quantum and classical computers for kind of joint jobs that use both of these systems in tandem. And there's a lot of fun kind of near-term applications using kind of hybrid stuff. Um, I guess a couple of really important terms you'll see in media, and it's just good to know in general. Quantum advantage is a term that's thrown around a lot, right? And that's kind of some jargon that's used to talk about a time when a quantum computer can perform a calculation that a classical computer can't reasonably do. Sometimes people call that quantum supremacy.
Hmm.
I'm more partial to the term quantum utility, when a quantum computer should practically be used, when it makes dollars and cents to use it over the classical computer. And I guess one final one is a lot of people talk about the era we're in for quantum computing being called this NISQ era, NISQ, noisy intermediate scale quantum, is the kind of this regime we're in where the hardware is being developed. We're scaling up in the number of qubits, kind of the processing units for these systems, but they're still noise prone, and we're working on trying to correct for that error.
Yep. So you mentioned qubits. Just hopefully help the audience and myself. I'm familiar with bits, right? And
Yep.
megabyte. So is a qubit is that many bits in
No, no,
essence?
a qubit is literally a quantum bit. Quantum computers use quantum particles to do their
Okay.
programming, right? classical computers have kind of these gates that use electrons, and if the gate's closed, it's off. If the gate's open, it's on, 0 or 1. A qubit, you're really using quantum states to do your computation, and there's a lot of different ways to make quantum computers. So there's a lot of science and stuff going around there, but
Yeah.
it's really interesting. Some people are using actual atoms, right? They're trapping atoms in the air
Oh, wow.
using lasers to do it, and some people are using light as their quantum particle. And some companies like IBM use a kind of way to make their quantum computers where they have these electrical coils that they reduce to ultra low temperatures so they become superconducting, and they call those superconducting qubits.
Huh. All right. So then I guess that leads into my next question perfectly, right? I mean, so what kind of technology do I need to do to run a quantum computer? Basically, I mean, am I looking for some sort of massive supercomputer? Is there some type of technology that I need to do this?
Yeah, certainly there's a bunch of companies out there that will sell you like an on-prem quantum computer. You can buy one of these. They're multi-million dollars at this point, but because they're kind of big and bulky and being developed and scaling out larger, a lot of companies are deploying this on the cloud. So to run it,
Yeah.
you don't really need more than a laptop, right? You
Okay.
can access it the same way you would access like AWS or Microsoft servers for some HPC time. You buy on a supercomputer, you would buy some time on a quantum computer.
Gotcha. Gotcha. So it's not a and there obviously I'm sure is an upfront investment there to do that because you're buying that time. And I don't know how expensive that time is
Mhm.
um, compared to anything else, but you're not talking about large scale infrastructure installations or anything.
Exactly, exactly.
Yeah.
A couple of companies are investigating that and having it on prem for their own uses, but most people are, like I said, just kind of you know, building and the programs on their computer and then running it on a quantum system. And most of the time at these skunkworks projects different companies have, or even universities and their graduate students doing stuff, they run their programs on simulators first, kind of simulated quantum computers.
Mhm.
Some of those are free, some do cost money, but a lot of them available are free to just test before you actually run on the real hardware and buy time on it.
Yep. So I assume the whole point of doing this of quantum computing is to do large scale computations at much faster speeds. So from a supply chain perspective, why would we need to be conducting computations at this scale or at this speed at these kind of speeds?
Yeah, that gets into kind of where quantum computing fits into computing, right? Why would we want to use it? Where are we trying to use it? And where do you see kind of the advantage of using quantum computers? And for supply chain, um, gosh, it hits a number of different sectors because quantum computers are really good at solving certain classes of problems. It's really good at solving things like systems of linear equations and optimization problems. And optimization problems is everywhere in supply chain.
Yeah.
Um, and it's definitely going to have huge impacts on that. And let's see, like whenever one of these major trade routes gets blocked out, like the Panama Canal or the Suez Canal, cargo ship goes sideways in it and blocks the channel for a week. Every supply chain has to re-figure out their routes. How do you get materials to different places? How do you ship things out? These are really computationally intensive tasks for classical computers to solve out. Right? It's not something that you could do simply or quickly or in real time. There's just so much data that you'd have to process and chug. And here, quantum is an enabling technology. Using a quantum computer, those kinds of problems are just going to be less resource intensive and will allow for more real time computation of this. So, like I said, logistics and routing, supply chain planning, scheduling, even kind of demand forecasting or risk management are all things that quantum computing are going to be able to help out with.
So this is as I'm listening to you talk, this sounds like this is really beneficial for planning purposes, right? And not necessarily in real time decision making.
In the short term, it's definitely going to be kind of planning out, right? As we're scaling up in the hardware, the more near term applications for quantum are things that you're not so worried about the speed of the computation, right? I know some people in finance are interested in quantum. And I always tell them we're not doing high frequency trading
Yeah.
on a quantum computer anytime soon, right? But as the technology scales up, we can get to a real time, doing this in real time and doing it for speed. But I would say that that's kind of 10 years out. You know.
Yeah. Okay. So for now, it's like think of it as you might want to utilize it. Think of it as how you can plan and optimize your networks and your operations
You got it
at this
exactly.
point. So, I mean, you mentioned several. There are several different areas that this can fit into. Is there any part of a supply chain organization right now that would most benefit from quantum computing?
Yeah. I always like to be realistic about where quantum is and where it will be. Today, to deploy quantum, you're not going to get an advantage using a quantum computer over whatever your processes are today.
Mhm.
A lot of companies are investigating this for advantage in 3 to 5 years. And they're doing this to build out their digital transformation roadmap because you can't just go to your IT team and say let's start using quantum.
Yeah.
um, and especially if it's going to hit anything that's client facing or things like that, you want to make sure that it's transitioned well. You don't have breaks in service. But I do want to set the expectation, right? Nobody in the industry is making dollars using a quantum computer today. But we are scaling up in the industry so that we can see this advantage, within that 3 to 5 year time frame.
So if I was to compare it to something for the people listening, then would this be similar to maybe where AI was 5 years ago? Right, we kind of talked about it, but you need to start planning for it, but you may not be incorporating it quite yet.
Yeah, I'd say so, right? And even the analogy with everything happening with ChatGPT and how that kind of hit the cultural, zeitgeist. To all of a sudden, like, everybody was aware of AI. We're probably going to see something similar in quantum, right? A lot of people are using it, exploring it, advancing it, and looking at it for a lot of business and strategic reasons. Heck, a lot of businesses are patenting quantum technologies and trying to make sure their company's IP is protected for this strategy. But we're probably going to see in a few years some company come out with some really cool quantum application or say that they made their clients a lot of money using quantum. And then all of a sudden, everyone's going to get interested in quantum in the same way. Suddenly, AI hit everyone in the face like, oh my
Yeah.
God, this is a cool thing. And then you realize actually it's been in our cell phones like the whole time, AI and stuff like that. You
So
turn around and realize it's been around.
so this is probably as you're talking, I'm thinking that this is probably a technology that's likely going to be adopted first by the large organizations, the large enterprises, and then trickle down.
Exactly. Yep. That's exactly the kind of case and what a lot of people see, right? Um, Everyone is seeing this same trajectory. A lot of Fortune 1000 companies are going to adopt it first, use it for advantage, deploy it to their clients. Once that happens, probably the technology is going to scale, right? We're going to have OEM manufacturers consolidate on what type of quantum computers they're building for. Prices will get cheaper. More people will be able to use it. And,
Yeah.
kind of the route technology takes in that, right? Same way with classical computers.
Yeah. So it sounds like it's being used to some extent in the supply chain, but maybe not widely used at this point. Is there any sense as to how much it's being utilized at this point, and are there any real world pilots projects that are actually happening with quantum computing, or are we just really kind of in the exploratory phase?
Ooh, that's a good question. So a lot of places are using it to, gosh, for a whole bunch of projects. A lot of automotive companies are investigating this, and some of them are definitely doing some supply chain and kind of logistics, projects. Like I know they're not our client, but I know Volkswagen did a really cool project where they re-optimized their paint shops for their cars, just because every time you have to switch out a paint can, that's lost time, that's lost materials. So re-optimizing their paint shops using quantum computing was able to save time on how long it takes to paint one of these cars, save material costs in the loss of material when you swap out these paint cans. And that's not to say they couldn't have done it with classical computing. They used it mostly as a test case for quantum. They wanted their engineers to know how to deploy this. Where can it affect their supply chain? And so that when kind of the hardware gets there, they know how to deploy it more widely.
Yeah. So what is yeah, whether it's that example or another one that you maybe a client that you guys have worked with, what kind of outcomes do you see when someone tests out quantum computing? I mean, you mentioned that. I mean, is that just a trying to understand better where to put different components, different equipment kind of thing? What's the kind of outcome that you look for with a quantum computing project?
Yeah, gosh, so many companies come to us for multitudes of different reasons. Whether it's better scheduling, better better vehicle route optimization, logistics, things like this. We've seen a lot of companies come to us with a sort of the traveling salesman problem, if you're familiar with that, right? Trying to get to multiple shops or multiple factories and back to your original destination in the shortest amount of time possible.
Yeah,
It's a really key example of where classical computers have a really hard time solving this class of problem, and it happens to be that quantum computing is really good at solving that class of problem. Um, so we see a lot of clients coming to us, doing that class of problem for various applications, whether it is, like I said, vehicle route optimization, scheduling, materials, delivery, things like this. um, it's it's an industry and a place where a lot of clients are investigating this and exploring this and wanting to create tools to compare what classical and quantum those solutions look like. Because not everyone's using an HPC supercomputing cluster to do their optimization. Maybe there are cases where, hey, buying some time on an IBM or AWS quantum computer could get you to a better vehicle route optimization plan, or route. So there's some really cool test use cases that we worked with clients on. I think even I presented this at a conference last year at a autonomous vehicles conference. Uh, Client Infosys, they kind of work with lots of other companies, consulting company, and they built a GUI application off of our platform, which is just really cool to show people in tangible, dollars and cents, what the classical versus quantum computation of kind of vehicle route optimization problems look like. If I put some pins on a map, what would the quantum solution be, and what would the classical solution be side by side? And a lot of clients want to see that at first, right?
yeah,
They want to compare quantum in a way that it's a problem they've solved classically before. They can see what the quantum solution looks like. It helps them get their feet wet, trust the technology, and see if there's any advantage in it, right now.
yeah.
And often the answer is no, no advantage right now, but that doesn't mean we're not going to have advantage in 2 3 years. So building up that skill set and honestly hiring the people who can program these computers is important.
Yeah. How different does the solution end up looking? Typically, I mean, is there a wide variance in the type of solutions that a quantum computer comes up with versus a classical computer?
Well, the thing is, we're hoping that the quantum computer, when the hardware scales up large enough, right, we can prove out mathematically that a quantum computer can get to a better solution faster than a classical, right? Pen and paper, with the physics of it, there's certain class problems, right? People call them like NP hard problems. Quantum computers can just solve more efficiently with less resources.
Yeah,
That makes certain problems just doable that you couldn't really do, and people just haven't really chased doing in real time or for accuracy. So hopefully we're going to be using quantum computers soon to get more accurate solutions for problems that maybe for speed reasons you were using a lot of heuristics or kind of intelligent guesses to simplify or speed up your calculations, where the quantum computer can actually chug the real data and get you more realistic solutions, using all the data that's in front of you, and kind of almost making good on the promise of big data, right? We were
yeah,
promised for so long all this, big data is the new wave of technology, and it's out there. All the data and technology is physically out there. We just can't chug the amount of data we're collecting. Hopefully quantum computers can process all that data coming in, to our industries, and help us with getting more accurate supply chain
You,
forecasting. And
you say that, and I'm thinking back. I was at a conference just a couple of weeks ago, and I was talking to a guy, and he says, "Yeah," he says, "the data." He says it just keeps changing names. He says it was big data, and then
yep.
it was machine learning, then it was AI, now it's Gen AI. He says we still have the same problem. We just have all this data we can't use.
Exactly. And I'm hoping, right, quantum computers are going to be able to chug that data more efficiently than classical computers.
Yeah,
There's a lot of cool machine learning applications for quantum computing that will also hit kind of the supply chain too. It's some really cool space, and I think it's going to be the thing that's going to enable all that big data that we have collected. Right, there's so much data that we can use to leverage for businesses that is just going unmanaged, unused, unutilized, and hopefully we'll finally be able to leverage it.
Yeah. So I want to get to my next question, but I want to go back to something you mentioned a few minutes ago, because just ask you this question about it. You talked about some companies needing to kind of hire these people, right? That can do
Yep.
this. Where is that workforce coming from?
Yeah, every quantum conference I go to, I hear about the quantum talent shortage. Uh, right, it's a big deal. All these major companies are investigating quantum in one way, shape, or form. Either they have a huge team or a small, skunk works operation where they're kind of investigating where it can apply for their business. A lot of companies are investigating this and wanting to hire talent. But frankly, there's not enough talent graduating out of universities who know how to do this stuff. So
Yeah.
universities are starting to offer quantum computing degrees,
Okay.
so a lot of companies are forced with trying to hire this small pool that's graduating every year. Or should we, upskill our own, computer science engineers, our own computing developers? And it's a trade off. Which one should I go for? And frankly, companies like Classic, we're trying to make it easier to get into quantum computing. So you don't need to have so much knowledge getting into this. And so, more like a computer scientist can use quantum computers. You don't have to touch so much of the physics of it uh, to use the hardware.
So are we at this stage? Are these people basically coming from developer ranks, and we need to kind of move to the point where we can use the data scientists for this, or is it can you come can are they coming from any both ends of that, if you will?
Yeah, that's the bottleneck right now. A lot of programming for these systems, kind of the state is assembly level programming, right? So if you work with IBM, you're going to be programming in their assembly code called uh, Chasm. Microsoft has a programming language called Q Sharp to interact with their hardware. And whether it's classic or other companies, the industry needs to move towards higher level modeling languages that just make it easier to interface with the hardware.
Yeah.
Um, so right now, the bottleneck is that you do have to have a lot of quantum knowledge to know how do I interact with the physical hardware components, in this stuff. But higher level modeling languages are making it so that you don't need to have that physics degree to start programming these systems, right? You can come from the ranks of computer science.
Yeah.
And that's what we're hoping to leverage and move forward. And other companies are trying to do the same. The industry is moving towards this area of computer scientists with this skill, but right now the bottleneck is it's physicists that you're having to hire.
Yeah. And like I mean, that's one of the things I've loved about Chat GPT is
Mhm.
that I don't have that background, right, in artificial intelligence, but now I don't need to.
Exactly.
Right. So we need to get to that point, right? So where people can do it and you don't have to have that background in quantum development.
You got to get to a
Yeah.
place where you can enable more people to leverage this amazing technology.
Yeah. So as you talk about this, you touched on the fact that we're kind of early in the stage. I think, right? We're kind of early innings, if you will, in deploying this. So, how soon till quantum computing becomes a must-have for supply chain organizations, something they can't live without, or something they actually has to have in order to reach efficiency levels that they're looking for?
Yeah. I think honestly a must have would be about 10 years out.
Okay.
It is a bleeding edge technology, and a lot of people who are adopting it today are doing it for kind of competitive advantage reasons, right? To win out on kind of these very important contracts where efficiency and these small gains are really important and would separate you out from the competitors. But for most supply chain organizations, right, a must have to keep up with the competition is going to be about 10 years out when you can have more wide adoption of the technology.
Yeah. So you, I think probably a bunch of people might sit there and hear that and say, "Oh, well, that's so far out. I don't need to worry about it right now." I'm still trying to get my head around generative AI at this point, right?
Yeah, yeah.
Right? I'm still trying to figure that out. So when we reach the point, whether that's when you reach the point that that organizations start implementing it, whether it's next year, whether it's later this year, whether it's 3 years from now, is this something that you expect would be easy to integrate into your operations, or are we looking at steep learning curves with hiring people that need to understand all this stuff? And what's that integration kind of look like and deployment
It's
look like?
Yeah, it's probably going to be a sliding scale as the technology evolves. Right now, it's more of a heavy lift, right? To hire on the talent, right? Like I said, we're a platform classic here that's trying to enable it and make it easier.
Hmm.
But there's a small talent pool that's coming out learning through kind of a assembly level, mode. So it's a heavier lift today, and as the technology matures and grows out, we're going to have easier, more connected systems. It's going to be an easier lift as it gets more widely adopted.
Yeah.
So like where I could see some short-term gains, certainly I'd say if you're looking to maybe deploy machine learning algorithms using quantum computing for like, I don't know. I'm prognosticating at this point, but I could see some object-oriented detection of anomalies for inline metrology. Right? You have all these bits being manufactured for different components. Hundreds of thousands of plastic parts. If a single part gets to your end user and it's out of tolerance, the whole shipment has to be sent back. Right? That's a huge loss of material. If you can come out with even a better ratio, say that you have a more accurate metrology setup than somebody else, that might mean you get more contracts than the other machine shops or other demand, just through that kind of demand spec. So I could see some places wanting to deploy it sooner rather than later for a lot of reasons,
Yeah.
but it's going to be a little bit heavier lift early on just because the technology is new.
Yeah. That's true. I think of every technology, right? I mean, the early adopters get an advantage, but that advantage comes at some sort of a cost, right? And that cost is
Exactly.
a little more heavy lift, maybe more investment, than later adopters can get.
You got it.
So, yeah. So I think you've touched on some of this in some of your answers, but kind of try to summarize a little bit here. I think in one simple question, I kind of view this as, in my mind, it comes down to one question for me if I'm a business, right? And
Yeah.
if I adopt quantum computing, am I looking at making better decisions with it, or am I just simply making decisions faster?
Right now, you'd be making better decisions, right? That's the short term gain of it.
Okay.
Again, right, if you start doing it today, realize that those better decisions are going to come between 3 and 5 years out, not today. You'd be investing for that kind of a better decision. Longer timeline, you could expect faster decisions.
Okay. So, this is an ROI kind of investment at this point,
Exactly.
then as well. So, what are you looking for? What's your long term ambitions here? Are you short term? If you're 1 year, 2 year out kind of thing, what do you see, and where can you make that? So the last question I have for you, as we're running low on time, a very broad question. I'll see where you take it. Right?
All right.
When we talk about supply chain management and quantum computing, what do you see the future holding there?
My gosh. Honestly, the future of quantum computing is so wide and diverse just because it does hit on so many kind of core types of computation. Like I said, quantum computers are really good at solving optimization problems, solving kinds of linear systems of equations. It can do some great things for machine learning and neural networks. So you're going to see quantum in a lot of spaces at the end of this journey, right? You're going to see quantum algorithms and quantum, essentially the end product of quantum systems being used in a lot of our everyday life without people noticing for the most part, the same way that kind of AI snuck up on us.
Yeah.
Um, Most problems, if you look at it, you can reduce to an optimization problem, right? Um, Gosh, I had somebody even talk to me about once they were trying to optimize their whiskey barrel placement. Because apparently, I didn't think about this when you have when you're loading up your whiskey barrels in that warehouse. There's humidity gradients, heat gradients on how high you stack up the barrels, how far back you stack it,
Yeah.
how soon you might need to move this out. It's At the end of the day, we're going to see it in a lot of applications. It's going to enable um, better forecasting for a lot of supply chain environments, and it's going to allow, at the end of the day, real time kind of dynamic data utilization. It's going to be a simple matter. If one of your shipping routes gets blocked, you're going to be able to click a button and figure out, okay, how do I reroute this? If your parts or your shipments doesn't come in for one of your suppliers, you can figure out much easier, how else do I resource this, or how do I, figure this out. You're going to see a lot of uh, faster computation, better computation, and a lot of people not even knowing where it comes from, because the end of the journey for quantum is going to be integration into the HPC stack.
Yeah.
It's going to be integrated with CPUs and GPUs. You'll have, like we talked about earlier, QPUs, and the right data will be sent to the right processor for the whichever one's best and most optimal for it. I always tell clients, we're not making Zoom calls over a quantum computer, right? It's really good at solving certain classes of problems the same way, GPUs are really good at solving certain classes of problems, not everything.
Yeah. Yeah, Eric, thank you for the time today. Greatly appreciate it. We could go on, I think, for hours on this topic, probably, and dive in much deeper than what we did today. So
Yeah.
there may be a lot of people out there that may want to know more. That maybe their interest and piqued in this topic. So how might they get in touch with you or Classic if they want to kind of touch base and learn a little bit more?
Absolutely. Like I said, right, we're a software development platform trying to make it easier for people to get into quantum computing, leverage quantum computing. If you want to know more, you can go to our website at classic.io. Classic spelt with a Q at the end, because every quantum company, I think, has to have a Q somewhere in their brand name. Um,
I think you should throw a Q into every word anyway, even if they're silent Qs. I just think that's a great thing.
oh my
but
gosh,
so
it's
so
a fun
yeah.
industry, yeah.
So classic classic.io for
You
those of you
got it,
listening.
perfect.
You got it. That's all the time we have for today. I want to thank Dr. Eric Garcelle of Classic for speaking with us today, and a special thank you to all of you out there listening. We greatly appreciate you spending time with us today. A new episode of Talking Supply Chain comes out each Thursday on scmr.com, so be sure to subscribe. You can go there and catch the episodes, or subscribe wherever you get your podcasts so you don't ever miss one of our episodes. Until next time, this is Brian Straight, and you have been listening to Talking Supply Chain. Talking Supply Chain is produced by Supply Chain Management Review and Peerless Media. You can find it on scmr.com, supplychain247.com, iTunes, Google Podcasts, or wherever you find your podcasts. For more information on this topic or to sign up for our weekly newsletter, a print or a digital subscription to our publication, visit scmr.com. We hope you will join us for our next episode. For Supply Chain Management Review, I'm Brian Straight, and thank you for listening.